Hi, welcome to your first PACE video. I just want to take a quick moment to remind you a little bit about how you want to take notes to be as successful as you can in this class. The first thing you want to do is make sure you title your notes for every section every day. In fact, title everything. Title your practice, title your learning logs, title your reflections. You want to title anything that you start writing down on a blank piece of paper. You also want to write down your questions as soon as you form them. As soon as you think you might be starting to form a question, pause the video. You will need them for the discussion page, the reflection, or in tutoring, but really you just need to remember your questions because you want to be able to get them answered. Next, make sure you're pausing the video often. I suggest you pause the video at the beginning of each slide to pre-read what's already on the slide, maybe copy everything down that you think you want to make sure is in your notes, and then go ahead and play the video for that particular slide. Make sure you pause the video to write down your questions as soon as they occur to you. You can use post-it notes, you can use a margin where you write all your questions and the answers. You can have a window of separate questions open, however you want to organize that is fine. And you also want to make sure you pause the video at the end of the slide to make sure you've copied all of the notes from that slide and that you review the slide and you don't have any questions for that particular idea. You want to make sure that you're rewinding the video as much as you need to. You can rewind the whole video or you can watch pieces at a time. Now go ahead and pause this. Make sure you copy these instructions as a note so that you know what you need to do for every video going forward. Every video will always start with some learning objectives to give you an idea of what we're going to talk about. It is a good idea to include these in your notes because these are topics or skill sets that you want to make sure you're able to do for the mastery checks. So this is Unit 1, Section 1.1, Interval Notation. In this video, we are going to use interval notation to describe the solution set to an inequality, or we're going to use interval notation to describe the domain and range of a function or relation. This should say of a function or relation. I'll have to fix that later. Okay. So make sure you are titling your notes. Have you done that yet? If not, pause it and do that now. Make sure that you are using the margins to write down your questions or post-it notes. So if you don't have those ready, go ahead and pause the video and go get those now. Make sure that you are pausing the video as you need to. So if you need to pause the video right now, you can pause the video in the middle of a word. It doesn't matter. You can always rewind if you need to. Make sure you write everything down. You will not remember it if you don't write it down, and especially with questions. Okay, so what is interval notation? Interval notation uses the endpoints of a set to communicate the entire solution set of an inequality. Parentheses and brackets show whether the endpoints are included, which we call closed points, right? Or excluded, which are open points. And you should be familiar with closed points and open points from Algebra 1. Overall, we're going to use brackets for those closed points. And we're going to use parentheses for those open points. Really, I should have switched the colors around here. So this should be red, right? Closed points in red and open points in green. All right, there we go. Closed points, of course, mean that it could be equal to, or it could be less than, and then greater than, of course, or equal to. And then open points means that it's either strictly less than or strictly greater than, but not equal to. Okay, let's do some examples. So if we have a number less than 3, a number less than 3 means that if we're at 3, we are going to go less than 3 this way, but we're never actually going to be equal to 3, so we use that open circle that we were just talking about. And that open circle means strictly less than, right? So the inequality would be a number x less than 3. Set builder notation, if you're not familiar with it, you should Google it. If you are familiar with it, fantastic. So we always use fancy parentheses. That means the set of x where x is less than 3. And then the fancy bracket ends the set. So the set where x or sorry, the set of x where, that's this line, where, this line literally means where, x is less than 3, and that's what that means. Okay, so for interval notation, remember that our closed points were red, right? Our closed points are brackets, right? Were closed points, so that meant they could be equal to. And our parentheses were open points, which means not equal to. And so if you notice right here, we have an open circle, which means we're not equal, and this is strictly less than, so not equal to 3. And this goes all the way down to infinity. Okay, so interval notation is the interval from -infinity to 3. And of course, you can never equal infinity because infinity is not a number. And the 3 and parentheses around both. And this would be considered interval notation for x less than 3. How about a number greater than or equal to -7? So if we graph -7 on our grid and say greater than or equal to, so we can be equal to, right? So we're going to do a closed circle right there. So greater than or equal to -7. Greater than means we're going above -7, so that means we're over here, right? So then the inequality would be x is greater than or equal to -7. And the set notation would be the set of x where x is greater than or equal to -7. That should be a negative, there we go. And then interval notation, we have a closed point, right? So that means we're going to use a bracket. And this graph tells us that we start, if we go from left to right, we're going to start at -7 and we're going to go up to infinity. But we can equal -7, so we use the bracket here and the parentheses here because, of course, we can't equal something that doesn't exist, and infinity doesn't exist. Let's try this one. A number greater than or equal to 2, but less than 5. Okay, so we need 2 graphed and 5 graphed. And greater than or equal to 2, so that means we can be equal to 2, so we're going to have a closed point at 2. I'll do this in green. We have a closed point at 2. Less than 5, meaning an open circle at 5. And so all of the numbers that are greater than or equal to 2, but less than 5 are in between here. Greater than 2, but less than 5. So in an equality, it's going to be 2 is less than or equal to x, right? Because we have a closed circle here. But less than, strictly less than, because we have the open circle, right? Strictly less than 5. So in set builder notation, if you haven't noticed yet, whatever is here ends up here, right? Whatever was here ends up here. And that's not a coincidence. So we have the set of x where 2 is less than or equal to x, which is less than 5. And we end the set. Okay, so our interval goes from 2 to 5, right? So from 2 to 5, where we can be equal to 2, so we have a bracket here, but we're strictly less than 5, so parenthesis there for the 5. Let's try one more. A number less than -1, less than -1. Okay, so we need a point at -1, and greater than 4, so we need another point here at 4. If we're less than -1, that means we're not equal to -1, right? We have an open circle here. And greater or greater than 4, so another open circle here at 4. And then if we're less than 1, we're down here. Less than 1, so that way. Or greater than 5, or sorry, greater than 4, so we can be up here. Right, so this is an OR graph. So in an inequality, we're going to need 2 statements. We're going to say x is less than -1 or x is greater than 4. In set builder notation, same difference, only instead of or, we're going to use a comma. So we're going to say the set of x where x is less than -1, comma, x greater than 4, and end the set. And in interval notation, we actually have two intervals. We have this interval, right, going down to negative infinity. So we go from negative infinity to -1, where we can't include infinity, and we have an open circle here, so we don't include -1. And then if you remember the union from geometry, a u, you can also use a comma if you want to, but the u. And then we start back up at 4, but we don't equal 4, and then we go to infinity, to positive infinity. And so that would be the interval notation for each of these. Okay, so each row, right, are all the different ways, these are all the different ways to describe the number set that is less than -1 and greater than 4. Okay, so I want you to go ahead and fill out the chart just like we just did, only in one I gave you words, I gave you an inequality, I gave you one in set builder, and I gave you one as a graph, a number line graph. So I want you to go ahead, pause the video, take a moment to do this, and we'll be right back. Okay, welcome back. So here's the first set if you need a little to double check your answers. Pause if you want to continue on. Next set. Third line. And the fourth line. Okay, make sure to pause the video if you want to look over this a little bit more. Okay, so identify the domain and range of each relation or function. So we need to remember that domain is the set of all possible input values, which on a graph are x values, right? All possible input values. And the range is all the output values, which on a graph are all the y values, right? So when we look at this, if we look at this graph right here, okay, if we look at our x-axis, we notice that this graph is going to go all the way to the left to infinity, right? It's going to go all the way this way. And it's going to go to the right to positive infinity. So the domain, all the possible x values are all real numbers, right? We can go all the way to negative infinity. We can put any x value in we want, and this graph will be okay. And so our interval notation would be from negative infinity to infinity, with, of course, parentheses because you can't equal infinity. The range, however, doesn't go from negative infinity to infinity, because when we look at the range values, right, the range values, there's nothing down here. And so if we come up and come up and come up, all of a sudden we have a value for y, and then we come all the way up and y continues up forever. So our y values actually start at 0 and go all the way up to infinity. We can never actually equal infinity, but when we look here on the graph, we do actually equal 0, so that is included. And so we say our range is from 0 to infinity, including 0. Okay, how about this one? Assume that this goes on forever, and so a graph comes down like this, and it goes up like this. And so when we look at the domain here, we recognize that this graph is going to go left forever, and it's going to go right forever, and it doesn't look like there are any breaks in the graph, so our graph is going to go from negative infinity to infinity. And our range, again, looks like it starts here at 0 and goes up forever, so our range is from 0 to infinity. Just as you were wondering if the domain is always negative infinity to infinity, here we'll talk about what these are called, but you notice that this graph, it looks like it goes up and then all of a sudden it jumps back here. And so this graph is not continuous, it's actually called a discontinuous graph. And when we look at the domain, it looks like all the x values come in here from negative infinity, right? And so we come in from negative infinity, and it looks like they get really, really close to -2, but then it kind of like veers off as if it's like magnetically pushed away from ever equaling -2. So if I put in like a dotted line here at -2, you'll notice that the graph never actually goes over the -2. So we go up very, very close to -2, but our graph never actually equals -2. it kind of jumps over -2. And so we're going to use the union notation to say our graph is going to go from -infinity all the way up really close to -2, and then it pops over -2, and then it continues from -2, and it looks like it does the same thing again at +2. And so we can write another interval notation, -2 to +2. And then again, it pops over -2, and then the graph comes here, and it goes out to infinity. And so a union with 2 to infinity. Okay, let's look at the y values. We notice that these both go down forever, right? So we know we have y values all the way down here. But if we look, it looks like it gets really, really close to 0 when y is 0. But it doesn't look like it actually touches. It kind of comes up here, right? So we go from -infinity to 0, and we get very, very close to 0, but we don't actually equal 0. And then it looks like there's kind of like this invisible line, kind of like there was a vertical line. They're called asymptotes, but we'll talk about them later. So it looks like there is kind of this like thing that's keeping this graph from touching 0. And so it's going to kind of jump over 0 here, and then if you look, the graph does continue up to infinity. So it looks like our y values go from -infinity very, very close to 0, and then we pop over 0, and then we go from 0 to infinity. And so that is how we would write the interval notation for that kind of a graph. Okay, so I want you to go ahead and try this graph. Remember, the domain is the set of all possible input values, and the range is the set of all possible output values. Remember, we call input values on a coordinate plane as x values, and the output values are generally called y values. So go ahead and take a moment, pause the video. Okay, welcome back. Here are your answers. And thank you so much for listening to the first video of your self-paced course. Go ahead and get that discussion page started. Don't be afraid to be the first one to post, and good luck on your mastery check.